Hello everyone, welcome to today's webinar. My name is Javier Ortiz. I'm your mentor throughout this course, Data Engineering Nano Degree by Udacity. So today's webinar will be focusing on data pipelines, building production data pipelines, and how to maintain them, and that's basically it. So before we begin, we're going to just a brief reminder of our study group, which resides in Slack, DEND session 963. Each week, I post a weekly roundup where I describe all the lessons that you have to study that week, as well with any scheduled events such as this webinar and the link to schedule one-on-one meetings with me. All right. So if you have any questions regarding any projects or any exercises, don't hesitate to ask me through Slack. That being said, let's move on to today's webinar. All right, and here we are. Okay, so today's webinar, as I already said, it's on building production data pipelines. And we'll start with what do I mean with that. Then we'll discuss three tools, which are operator plugins, refactor a DAG, and sub-DAGs. And I'll give an example of each of those. Right, so building a production data pipeline, it's all about answering this question: how to build maintainable and reusable pipelines, all right? So how can we build these DAGs, these pipelines that are easy to maintain, that anyone can come see your code and see exactly what were you thinking, and that are reusable? That means that if you are performing some actions regularly, that you don't have to write all the code from the ground up every time you need to run these DAGs, to create these new DAGs, but that you have it in specific packets so that you can take this piece of code and reutilize it in a new DAG, right? And the three main tools that we use for that are operator plugins, refactor DAGs, and sub-DAGs. So I'll explain each of those and how do they help us achieve our goal of building a maintainable and reusable pipeline. All right, so what are operator plugins? So what they do, they extend airflow functionality through plugins, right? So basically, this allows us to create specific functions, right? And to connect Airflow to some dependencies that run outside Airflow. Hooks and operators are the most common, and hooks, they help us connect Airflow with other dependencies, other systems, to maybe load information from other platforms. And operators basically helps us to run functions from different files. And they make DAGs reusable and simpler to maintain. All right, how do we achieve this? You have to think of an operator plugin as when you are importing a library, or when you import a function from a different library. So it's a specific function, so it performs a specific task, but it won't be on your main file. It's something that is already written in a different file. So you're basically importing this function from that file. And they make DAGs reusable and simpler to maintain, because if it is something that, a task that you commonly do or you commonly insert in different DAGs, since it's already in a different file, you can just use that file to import that specific function or that specific task into your DAG, and just initiate initiate a new instance of that function. And the way we do that is, first we identify operators that perform similar functions and can be consolidated. So if you always load from S3 to Redshift, And maybe that's something, that's a task that you can consolidate and write it in a different operator and a plugin, and that you can always import that to your specific DAG each time you need it. And after you have identified these functions, these operators that perform similar functions, you need to define a new operator in the plugins folder, because this is the place where you are going to import the plugin. And you're going to replace the original operators with your new custom one, reparameterize and instantiate them, right? So basically, you still need to do some setup, but it's a lot less than what you have to do if you were to write the operator in your file instead of having it like in a different one. So let me show you how does that look in real life. All right. So this is lesson 3, exercise 1. And here, let's read the instructions. We'll consolidate repeated code into operator plugins. You're going to move data quality check logic into custom operator, replace data quality check Python operator with our new custom operator, consolidate both the S3 to Redshift function into custom operator, replace the S3 to Redshift Python operator with our new custom operator, and execute that. So basically what we have here, we have identified 2 common tasks, okay, that we are doing repeatedly. The first one is we are performing a data quality check. Basically, we are checking if our tables have rows, okay? And we're doing that for several tables. So if we're using the same piece of code to check different tables, it doesn't make sense to have the same function. We can have that function in a different file, and then we can use it in all our DAGs that we needed. And the same for S3 to Redshift functions. So here, as you can see, this is the function that performs the check, that it checks if our table has any rows. And what we need to do is, instead of having it here, okay, because if you need this piece of code in a different file, you have to copy and paste it in a different file and make it work for that file. Instead, we can have it in a different file, and then we can use it for any DAG that we need. So we're going to erase this from here. And after we do that, we need to replace this data quality check right here and this one right here with the new instance of the function that we're going to place in the plugins, right? So instead of having this checks over here, what we're going to do, we're going to call the operator from the plugins folder, and we're going to instantiate them with the parameters that we need for this specific DAG. And then we can change this so that we can perform it following the new plugins operator. Right, so I already have the code written here. So let's just compare it. So the first thing that you're going to notice is that this function is gone. It's not here anymore. So where has it gone? Here in the workspace, you already have it in the plugins folder. If you open the operators folder, you will find these has rows .py, and you can see here that our function already lives here. Okay, which is really cool, because if I ever need in a different DAG this type of checks, I know I can just import it from this file. So there's no need to have it in the exercise 1.py, because we already have it here in the has rows. And then after that, you'll see that the check trips is no longer where is it? It's no longer it's not calling a Python operator, because that calls from the same file. It's now become an object that has row operator. and we name task ID, a DAG, and then we connect it to Redshift and the table, right? So it's a little bit different the way you set it up. And the same for the second check, right? And here at the end, I think you don't need to change anything, or do you? No, you don't, because you're using still the check trips. All right, so instead of calling from the function within the file, we're calling from the hash row operator, which now resides at the plugins folder, operators folder, and has its own file hash row, right? So it's not that difficult. It's not that, but it does make a difference, especially to now it makes it reusable. This function now is reusable many times across many DAGs, which before it was not. Right? So that's what we mean with operator plugins. And you can apply this to S3 to Redshifts, and there are just a bunch of plugins you can use. All right, let's continue. Cool. Refactor a DAG. So what does that mean? Sometimes you just build this function that basically does everything, and it makes it really hard because the function needs to follow some steps and in certain order. And sometimes if you refactor this big function into different functions, to different tasks, you can run some of these tasks simultaneously, and you can save yourself a lot of time and a lot of headaches as well, because if the function fails at some point, the whole function has failed and you don't really know where did it fail. Maybe the line will show in the errors log, but the whole function just failed. But if you separate this function into mini tasks, now you know specifically what task has failed, and it's easier to debug. So that tasks should be atomic and have a singular purpose. So if you have like this mega function that fulfills like 3-4 purposes, task, you need to make it smaller. That task should maximize parallelism, because sometimes maybe you're loading from 2 different S3 buckets. So maybe you can load those 2 at the same time, or if you're performing a check on 2 different tables, maybe you can check those 2 tables at the same time, because you have the power to do that. But if you have like this one function, you need to follow the order, and you are not optimizing for parallelism. Now that task should make failure states obvious, just as I was explaining. The task, the place where it fails, if it's small enough, you are going to be able to identify where that specific task has failed. Every task in your DAG should perform only one job. It's easier to write, it's easier to debug. And task boundaries are useful if you revisit a pipeline you wrote after a period of time, because you can understand what this small piece of code is doing, instead of this super big function. And the parallelization can offer speed up in the execution of our DAGs. As I was mentioning, you have the power to load many tables at the same time. So let's use that power, that capacity. So let me show you how to refactor a DAG. Let's move on to exercise number 2 at lesson 3. Okay, so we'll refactor a DAG with a single overloaded task into a DAG with several tasks with well-defined boundaries. Read through the DAG, identify points in the DAG that could be split apart. Split the DAG into multiple Python operators and run the DAG. So as you can see here, we have this big function. It's called load and analyze. And basically what it does, it finds all trips where the writer was under 18 using this hook. Then in the same function, we find out how often each byte is written. In the same function, we find out how it counts the number of stations by city, and so it does those 3 tasks. So as you can see, you're performing 3 tasks in the same function. So this is a good candidate for refactoring. And what we need to do is let's look at the different tasks that we're going to perform, and let's put each of those into its own function. So this one over here, that find subtrees where the writer was under 18, you can see here, we have now put it here inside this function log youngest. And here in the create youngest task, we are creating the table for younger writers, which we were previously doing here. So we have separated this super big task into a smaller task. Now we have this function to find the young writers, and we have this operators to create the table and to load the table. So that's pretty cool. And here we have the other task with the lifetime rights. Now we have it in its own Postgres operator, and the same for city, count the number of stations by city. We are creating its own table. So now we need to change the order of those tasks, because now load and analyze is gone. So we can create all this task and log all this task, create youngest task, and log a youngest task. And that's basically it. So we have broken up this huge function into really defined tasks. And the cool thing here is that we can do the create all this task and log all this task at the same time we're doing the create youngest task and log youngest task, which will speed up the process. All right, and that's basically it for refactoring a DAG. So let's continue. All right, let's move on to our final tool in our toolbox. So it's sub-DAGs, all right? And if you're used to using SQL, you can think of it as the same as subqueries. So basically, you write a whole query that is going to create a specific result, and then you can use that result inside another query. So it's like building a specific piece of something and then using the specific piece into a bigger, as it's a component of a bigger file or a bigger program. All right, so commonly repeated series of tasks within DAGs can be captured as reusable sub-DAGs. So let's say if you always load from S3 to Redshift, you can have a DAG that handles that specific task, and you know that DAG works, and you know, and that you can use it anytime you wish to use it. And so if you're going to build another program and loading from S3 to Redshift is going to be part of that program, you can take this DAG that you already built and just incorporate it as a part of that, and that new DAG, right? And it decreases the amount of code we need to write and maintain to create a new DAG, because obviously we are using from previously built DAGs. It's easier to understand the high-level goals of a DAG because you already know the different tasks that you're going to perform. Bug fixes, speed-ups, and other enhancements can be made more quickly and distributed to all DAGs that uses sub-DAG. Because if you're using the same DAG as the same file as part of 5 different programs, and you just need to fix that specific DAG if you find a bug, and all the other programs will benefit from that bug fix, which is not the case if you have that, if you don't have it in a sub DAG, if you have that piece of code inside each specific file, and maybe you have 10 or 20 or 100 of those, you will need to revisit each of those files, and it can be a headache. All right, so let me show you how to write this sub DAGs. All right, here we go. Exercise 3 sub DAGs. Instructions. In this exercise, we'll place our S3 to Redshift copy operations into sub DAG. Right. So this part S3 to Redshift, we're going to build it. We're going to use it from a DAG, from a standalone DAG, and we're going to consolidate hash row operators into the sub DAG and reorder the tasks to take advantage of the sub DAGs. So here, some part of the code is already written for you. But let me show you the sub DAG first. All right, so this is the sub DAG, and basically it returns a DAG which creates a table if it does not exist, and then proceeds to load data into the table from S3. When the load is complete, a data quality check is performed to certify that at least one row of data is present. So we are loading, we're creating a table, and we are shaking that table. So we're here defining the function get S3 to Redshift DAG, and the create task, copy task, and we're going to move the hash row operator task here from the DAG. All right, and I can show it to you here. As you can see, we have the get S3 to Redshift. This is the function. So this is just another DAG that you have built in the previous exercises. We have the create task with the Postgres operator, copy task, and here we are including the check task that uses the hash row operator. So it's using the operator plugins that we talked about in exercise 1. And you need to change the links between tasks, because first you're going to create a task, copy task, but from there you're going to check the task, which is the operator you just incorporated from the plugins. And once we have run this task with this DAG, then it's going to create this table, and it's going to check the table, and now we can use that table into our main in our main DAG. All right, and here, this is our main DAG, and some of the code is already written for you. So here we're using the trips task ID, and we were explaining that we're going to use the sub DAG operator, and we're going to use the get S3 to Redshift DAG. All right, and we're going to do the same for the stations table. So we have the trips table, the stations table, and the check trips that we had here, it's gone because now it's part of the first DAG. All right, and so we're left with the location traffic, and we need to change the ordering, because previously we had the trips, we created a table, but we checked them in our main DAG. Now that task is already performed in the sub DAG, so we don't need the check trips, and we don't need them for check stations as well. So we just go from trip sub DAG task, which creates a table and checks them, into location traffic task, and we can do the same for stations sub DAG task and into location traffic task. So that's pretty much it. It's straightforward, but it can be tricky to understand how are you importing from different files. but just need to just make sure that you understand that each function or each task should be atomic, should be really, really small. And you need to understand from which file are you importing these different operators or these different tasks, right? So those are the three main tools that we use to build maintainable and reusable DAGs. We're talking about plugins. We're talking about refactoring DAGs, and we're talking about sub DAGs, right? So hopefully that was useful for you. And next week webinar will be a walkthrough of data pipelines project, which in my opinion is the hardest project yet, which is I think is cool because this is your last project. So if you have any questions whatsoever, you need any help, don't hesitate to ask for help. And next week I'll provide the walkthrough, and as the last project. After that is the capstone project. I'll continue to record these webinars. If you have any specific topics you would like me to dive deeper into these webinars, please suggest those topics. Otherwise, I'll just teach you what or share with you whatever I think is appropriate or needed for your different capstone projects. All right. So glad to talk to you guys again, and see you soon. Have a nice week. Bye bye.